Good morning, everyone. I'm so excited to be here with all of you at HashiTalk India. Whether you are tuning in from your home, office, or anywhere else, thank you for joining me today. I am Nikita Maurya, a staff cloud platform engineer at AppDirect. I have been working in a world of cloud technology, automation, and DevOps for over 7 years. I'm passionate about using Terraform and infrastructure as code to create scalable, efficient, and cloud infrastructure. Along the way, I have earned certification like AWS Certified Solution Architect Professional, AWS Developer Associate, and Terraform Associate, which have enabled me to master cloud infrastructure and automation best practices. Today, I'm thrilled to share with you Terraform Everywhere, standardization best practices, and cloud integration. Feel free to drop any question in the live chat and I'll sure to address them at the end of the session. Let's dive in. Here, what we are covering today. We'll start with an introduction to Terraform and why it is the foundation of our infrastructure. Next, we will talk about the importance of standardization and refactoring, tuning Terraform into robust and scalable tool for teams. After that, I'll share the 6 best practices we follow at AppDirect based on the real world challenges and lessons. Then, the fun part, our migration journey from Terraform open source to Terraform Cloud. We'll wrap up with the benefits we have seen and of course Q&A for your burning question. So, what is Terraform? So, Terraform by HashiCorp is an open source infrastructure as code tool. It lets you define your cloud infrastructure in a declarative configuration language called SCL. Here, the power of Terraform. You can define infrastructure once and use it across multiple providers like AWS, Azure, or GCP. This is not only reduce manual work but necessary ensure consistency and version control for your infrastructure. Imagine this, you are not clicking buttons in a cloud console or running ad hoc script. You are managing your infrastructure like the manage your code like Git and workflow and automation. So let's talk about why standardization and refactoring are crucial. Without these practices, you end up with inconsistent code. Resource names don't follow pattern, modules are reused poorly, and teams struggle to collaborate. Standardization brings clarity, clear naming convention, and consistent structure. On the other hand, refactoring, that's where you take an existing code base and make it better, simpler, scalable, and easier to maintain. For example, modularizing commonly used infrastructure patterns like VPC, IAM roles, or security group. Think of this way, standardization sets the rule of the game, and refactoring ensures the game is played efficiently. Now, let's dive into 6 best practices we follow at AppDirect. Let's talk about modular code in a Terraform. Imagine you are building a huge structure and instead of recreating the same part over and over, you create reusable building block. This is exactly what we do with infrastructure in Terraform. By structuring infrastructure into modules like networking, security, and compute, we make our code scalable and maintainable. You can easily reuse the same modules for a different project without reinventing the wheel. That benefits it reduces redundancy, making it easier to manage and ensure your resources are always consistent. This is also simplifies update and changes because you can modify a module one place and the update automatically propagates across all instances. In short, it's about working smarter, not harder. Now, moving on the naming convention. Consistent naming isn't just about aesthetic, it's practical approach that makes your infrastructure easier to manage and troubleshoot. Think about how quickly things can get messy if names are inconsistent. Debugging issue, conducting audits, or collaborating with teammates become a challenge. For instance, we follow clear, predictable naming patterns using prefix like AWS instance for EC2 instance, Azure network for networking resources, or prod VPC for production VPC. This make it immediately clear with what each resource is, where it belongs, and which environment it is in. So when you look at a resource name like AWS instance dot web server, you instantly know it's an AWS EC2 instance running the web server role. This level clarity cuts down on the time spent figuring out what's what and improve efficiently across the board. The third best practices which we follow Terraform state file, okay, and the state management. So Terraform state file is its brain. It know what deployed. We use Terraform Cloud as a remote backend to store this state. This enable locking, ensuring no two developers can accidentally modify the same resource at once. After that, the fourth point is environment isolation. So we isolate environment, dev, staging and prod using Terraform workspace or separate state file. Terraform workspace will work in a smaller configuration or a smaller environment. But if you have a Terraform multiple projects and multiple environments such as dev, staging and prod, so you have to think about separate state files. This prevents conflict like accidental update to production when testing a new feature. Now, the fifth point is version pinging. So when we talk about best practices, version pinging is also a most important point. So provider and module version are pinned in our configuration to prevent breaking changes during upgrades. For instance, lock a specific version for an AWS provider ensures predictable behavior across deployment. The last point, and very important, documentation and comments. Clear comments make Terraform configuration easier to understand and maintain. Whether you are onboarding a new teammate or revisiting your code after a month, good documentation saves times and confusion. Now, after discussing the best practices, let's understand what is Terraform Cloud. So, a managed service for running Terraform with enhanced collaboration, security, automation features. So, that is Terraform Cloud. So, why to migrate Terraform Cloud? Okay, Terraform Cloud provides a more robust environment for collaboration and scalability compared to using open source Terraform with local state files or S3 backend. With Terraform Cloud, you get team-based workflow, secure remote state storage, policy enforcement, and integration with version control platform. It also simplifies access control and make it easier to scale infrastructure as team grows. Now, we will discuss more about the migration process and the Terraform open source to Terraform cloud journey. So the migration process begins with assessing your existing Terraform setup. You need to set up a Terraform cloud account and create an organization. Migrate your state file to Terraform cloud remote backend. And then third step is set up your version control system like GitLab, Bitbucket or GitHub. It is important to test a new setup in a staging environment before fully transitioning to ensure minimal disruption. So this point we have to take care of and point to note when we are doing the migration from Terraform open source to Terraform cloud. So let's discuss about when we talk about Terraform open source. So when you talk about Terraform open source, which means when you store your Terraform state file locally or a backend like S3 bucket. Here's a code snippet we have used for backend S3, where you can see the bucket where we can store the state file and the region and the DynamoDB to log the state file. So when we do the Terraform init initialize your Terraform configuration, download provider plugin and set up the backend. When using S3 backend, Terraform stores the state file remotely is an S3 backend, ensuring team collaborate and state consistency. DynamoDB is used to state locking, preventing concurrent changes to the state file. This setup ensures secure remote state management with versioning and locking, especially using Teams environment. So I have used this Terraform init, plan and apply to understand and give you the details about when we are doing the Terraform open source. These are the things and these are the apply commands and we have to apply from our local. So Terraform plan. The Terraform plan command generates an execution plan. It shows you that what Terraform will do when you run apply without actually making changes. It compares the current state from the state file with the desired configuration and provides a list of action, add, change and destroy resources. This is safety check. You get a preview of what Terraform intend to do, so you can review and confirm everything is correct before making changes to your infrastructure. Now, the final step is Terraform apply. So after reviewing the plan, you use Terraform apply to apply the changes. This command actually makes changes to your infrastructure, creating, updating or destroying resources. Before executing Terraform, will ask for confirmation unless you use autoapprove to skip this step. After applying, Terraform will update the state file to reflect the changes that have been made. So these are all steps that we have showed you recently. So Terraform init, Terraform plan or Terraform apply. These are we are doing when we are configuring Terraform open source and we are applying those changes from our CLI. So with AWS S3 dashboard, select the S3 bucket containing your remote state file. So you will find Terraform state file in the bucket. Now, to migrate to Terraform Cloud, first you need to create an HCP account and create organization. Terraform Cloud Organization is a container managing team, workspace, and access control. Think of the organization as the umbrella that holds everything together. It's where you manage teams like DevOps and infrastructure, workspace, and permission. It's also where you link your version control repository, GitHub, and GitLab and set policies using Sentinel. So Terraform Cloud Workspace is a unit within an organization for managing infrastructure. Workspace are where actual infrastructures are live. They represent a specific environment, example dev, staging, prod, and each has its own state file. This isolation of state means that change in one workplace won't affect other. So in order to migrate your Terraform open source to Terraform Cloud, you have to set up your organization and workspace. After that, you have to integrate your GitHub account and other variable to configure in such a way that we can start the migration process. So to migrate your state from S3 to HCP Terraform, you need to replace the backend configuration. Here you have to update the backend to Terraform Cloud and the host name will be Terraform Cloud URL. Organization, the organization you created in the Terraform Cloud and the workspace. So you have to update all these three and make sure that you comment the or remove the Terraform backend of S3 or your local one. So after doing the Terraform backend configuration, you can do the Terraform login. So Terraform login is basically you have to log into Terraform, which pop up the notification to create an API token, which does the job for your user authentication. Once that is done, you can do the migration plan or you can initiate the migration plan from S3 backend to Terraform Cloud. So when you do after login, you can do the Terraform init where you can see migrating from backend S3 to HCP Terraform. Once you migrated your Terraform state file, you can go to your workspace and select the state and then you can see the new state is been pushed. So when you're migrating from an existing environment or existing Terraform open source resources to Terraform Cloud, you won't see any further changes because you have did the brainstorming and understanding the things that you will migrate and no infrastructure changes apart from like outside of Terraform will occur. So that's the best practices that you can follow migrating from Terraform open source to Terraform Cloud. Now, our migration to Terraform Cloud brought several benefits. Let's understand key benefits and lesson learned. So, the benefits are improved collaboration with shared workspace and centralized state, streamed provisioning via automated workflow, enhanced governance with policy as code. However, we learned that proper planning and training are vital for a smooth transition, as team adoption and adjustment to cloud based workflow takes time. So, thank you all for your time and attention today. If you have any question or need further clarification on Terraform concept, feel free to ask now and reach out to me later. I hope this session helped you better understand how Terraform works and how you can leverage it for your infrastructure automation.